All right, so now we're going to begin looking at the unit circle and using it, as well as learning about some more trig functions that maybe you haven't heard of yet before. So our two goals for today are to identify the unit circle and evaluate trig functions using the unit circle. And you might remember from Algebra 2 that the unit circle is just a circle with a radius of 1 unit. So if I pick any point on the unit circle, then the equation x squared plus y squared equals 1 is true for all points, and here's why. If we look at this circle, and I pick any point on the circle, so let's say I pick this point P, okay? If I draw a radius to that circle, to that point on the circle, now remember, we said that a unit circle has a radius of 1 unit, so I know that this is 1. Now, if I look at our ordered pair, the ordered pair for this point is the point x, y, right? So if I think about what that means in terms of coordinates, I can then look at, well, if I were to draw a line that represents how many units I moved up, I could call that y. And if I were to draw a line or segment that showed how many units I moved to the right or left, I could call that x. So then because I have a right triangle here, I can then use the Pythagorean theorem. And the Pythagorean theorem would say x squared plus y squared equals 1 squared. And that's exactly what we have written up above. So what this does is it allows us to find the value of all 6 trig functions sort of generically. So let's talk about that. Now, you may not be familiar with all 6 of these functions, but for sure you are familiar with cosine, sine, and tangent. So we're using theta as our reference angle, right? So in this right triangle, if you remember back from geometry, you have SOHCAHTOA for any right triangle that indicates that you can use sine, cosine, and tangent and write a ratio using the sides of your triangle. So for cosine, I would say that is the adjacent side over the hypotenuse. So in my triangle, for angle theta, the adjacent side is x and the hypotenuse is 1. So the ratio for cosine is x over 1, which I could just write as x. Okay, so the cosine is our x coordinate. Pretty easy. If you look at the coordinate for P, we're just going to have our cosine is the x coordinate. Okay, next up is the sine ratio. So for our sine ratio, it's the opposite over hypotenuse. So for our angle theta, the opposite side is y, hypotenuse is 1. So our sine ratio is just y over 1, which I can just write as y. And again, to make this a little more simple, we can think of it as sine is just our y coordinate. And again, this is something that you learned hopefully in Algebra 2. Finally, back to our geometry days, tangent is opposite over adjacent. So if our angle theta is here, the opposite side is y, and the adjacent side is x. So our tangent is y over x. Okay, now another way I can write that, if you look back up above, okay, y is another way to say sine. So really, I could say sine of theta over, and then if I look at what x represents cosine. So I could say sine of theta over cosine of theta. That's another way that I can represent tangent. All right, so the next couple of trig ratios are going to be new to you probably. These are all what we call our reciprocal trig functions, and I'm just going to write that up here because they relate back to the original 3 that you know already, because they are just reciprocals of those 3. So secant is just going to be the reciprocal of cosine. And this is pronounced secant. Okay, so secant is the reciprocal of cosine. Now you can write that as 1 over x, or you can just think of it as the reciprocal of cosine. Okay, either one of those is fine. Cosecant then is going to be the reciprocal of sine. And what I said there was cosecant. So the reciprocal of sine then would be 1 over y. Or you can just literally think of it as flipping the sign, whatever the sign is. And then finally, cotangent. Cotangent is going to be the reciprocal of tangent. And once again, this is cotangent. So cotangent is the reciprocal of tangent. So a couple ways that I can write that. I could either write it as x over y, or I could write it as cosine over sine. And you could do either one of these, cosine of theta over sine of theta. Either of those is acceptable. Now, this is going to be very helpful for you to have as you're trying to do anything with the unit circle, especially initially, until you get used to the relationships here, because this will give you at a glance, what function does what. All right, let's practice a little bit. Okay, so let's find all 6 trig functions for theta in the unit circle below. Now, the key here is that I was told that this is a unit circle. So I know that this radius is 1. And then if you, again, think of drawing in those, excuse me, those measurements that would represent how much you move up and down and left and right, and then you can quickly see that 3/5 is how much I moved up, and 4/5 is how much I moved to the right. So I've got the lengths of the sides of my triangle if I need them. But if I want to find all 6 trig functions, I don't even really need to look at the triangle. So let's start with the 3 basic trig functions. So if you remember what we talked about on the previous picture, we said that sine is directly related to the y coordinate. So my sine of theta is just the y coordinate. My y coordinate in the triangle is 3/5. And again, that's because if I were to write this as a ratio, it would be 3/5 over 1, opposite over hypotenuse. The over 1 isn't necessary, so I just write it as 3/5. Next up, cosine. So, and you can even write that here if you need to. This is your y coordinate, okay? Next up is cosine. Cosine is directly related to our x coordinate. So if I look at my point has an x coordinate of 4/5. That is my cosine. Tangent will be directly related to sine over cosine. Okay, so let's look at what that does here. So the sine over cosine. Now that looks a little confusing, so let's talk about that for a second. Sine over cosine, if we're dividing fractions, that's the same thing as multiplying by the reciprocal. So we do 3/5 divided by 4/5 is really what's happening here. But that ends up just being 3/5 times the reciprocal of 4/5. And that's how I want to think about this, because then I have some giant ones happening here. That's a 5. Because I have this giant 1 right here, which then leaves me with just 3/4. So my tangent is 3/4. Now, you might find a quicker way to do this, and I'm going to let you guys kind of see if you can figure that out. We can even talk about some of the things that you find in class. But let's go ahead and find the next 3 trig functions. Okay, so next up we're going to find the reciprocal functions. Cosecant, 2 ways you can think about it. You can think of it as 1 over sine, or you can think of it as the reciprocal of sine. I'm going to work off to the side here. If I think of it as 1 over sine, that would be 1 over 3/5. Now that's complicated looking, but we'd have to go through that process that we just went through to simplify tangent. I would have to do 1 divided by 3/5, which is the same as saying 1 times 5/3, which ends up just giving me 5/3. But here's the thing. If I remember that it's just the reciprocal of sine, if I take sine and flip it, I get 5/3. So it's a whole lot faster to think of it in those terms. So secant, let me write that up here. So this is the reciprocal of sine. Secant is the reciprocal of cosine. Okay, so once again, I'm just going to look at what cosine is, and I'm going to flip it. So I'm going to flip it to be, instead of 4/5, be 5/4. Now, cotangent. Again, there's two ways we can do this. We could do the reciprocal of tangent, which would be just 4/3, or you could do cosine over sine. So there's two ways to think about this. I could either think of this as the reciprocal of tangent, which really, guys, that's just cosine of theta over sine of theta. Okay, so either one of these is appropriate. Now, if I do that, if I do it as cosine over sine, I'm going to have to do all of this simplifying again, because I'm going to end up with something like 4/5 over 3/5. If I think of it as the reciprocal of tangent, then all I have to do is flip 4/3, or flip 3/4 to make it 4/3. All right, so now I've got all 6 of my trig functions. I have sine, I have cosine, I have tangent, I have cosecant, secant, and cotangent. Before we start with the next example, I want to take a minute and talk about the unit circle with you. So it's very possible that last year maybe you didn't spend as much time on the unit circle as some of your fellow students. So I want to take some time and build this unit circle with you. Let's talk about, first of all, filling in all of our angle measures. So if we start at the origin, okay, that's a 0-degree angle of rotation. If we go all the way around and come back, that's a 360-degree angle of rotation. Now, in radians, that's 0 or 2 pi. If we rotate halfway, that's going to be 180 degrees or just 1 pi. Now we can start thinking of this in terms of, you know, a half a rotation, a quarter rotation, and so on. If I rotate to here, most of you can recognize that that's 90 degrees. Now, 90 degrees is half of 180, so this radian measure would be half of pi. So this will just be pi over 2. I can then think about, you know, if I rotate to this here, that's 270 degrees. All right, now you can think of this a lot of different ways, but here's a really easy way to think of it. 90 times 3 would give me 270. So whatever this radian is times 3 would give me my radian measure here. So that would just be 3 pi over 2. All right, so I've got my quadrants filled in as far as the angle measures go. Let's fill in the ordered pairs. So because this point, the center of our circle, represents the origin, and we know we're dealing with a unit circle where the radius of this circle is 1, this point out here would just be 1, 0. This point right here would be the point 0, 1. This point out here would be the point negative 1, 0. And this point right here would be the point 0, negative 1. All right, next I'm going to work on just my 30-degree rotations. So I'm going to label those with pink points. Now, the reason I know that all of those are 30 is, watch, from here to here, here to here, here to here, and here to here is 30. Okay, it's the same rotation from the x-axis. So I know that this is 30 degrees. Now, you can convert that to a radian using what we did in the previous lesson and make it pi over 6. So what I want to do is think about what these other angle measures would be. So I know that this is 180, and this is 30 degrees before 180. So I can really just do 180 minus 30, which would give me 150 degrees. I'm going to keep doing the angle measures in degrees here. So if I think of this angle right here as being 180 and then 30 more, that's easy enough. I can just add 30 to 210, or add 30 to 180 to get 210. Now this one's a little bit trickier, right? Because I'm ahead of 360. This is before 360. So you can think of it one of two ways. It's all the way around, or it's 30 degrees short of an entire rotation. So 30 degrees short of 360 would be 330 degrees. Now let's go ahead and fill in all of the radian measures. So I like to think about it like this. I can multiply 30 times 5 to get 150. So whatever this radian measure is, I'm also going to multiply by 5. And that's just going to save you time having to then convert every angle to radian measure. So then I can do the same thing here. 30 degrees times 7 would give me 210. So pi over 6 times 7 is going to be the radian measure there. And then finally, 30 degrees times 11 would give me 330. So 11 times pi over 6 is going to give me the radian measure there. Now, as far as the ordered pairs go, this all goes back to what we know about 30, 60, 90 triangles. And I'm going to go ahead and just draw one of those triangles in here. Let me get rid of these real quick here so you can see what I'm talking about. So we have this leg here and this leg here. And we know that this angle is 30 degrees, this angle is 60 degrees, and that would be a right angle. And then we know that the hypotenuse of our triangle is 1. So this goes back to your 30, 60, 90 relationships from geometry. I'm not going to go over all of those relationships right now. If that's something that you would like to see, I can post a separate video for that. But what we know is that the side across from 30 degrees is half of the hypotenuse. So this would be 1/2. The side across from 60 degrees is whatever the shorter leg is times radical 3. So I would do 1/2 times radical 3, which ends up giving me radical 3 over 2. Now what I know is that this length represents the x-coordinate in my point, and this length represents the y-coordinate in my point. So very quickly, I can figure out that we have radical 3 over 2 here and 1/2 here. Now, why that's helpful is that all of these other points are going to have the same exact lengths, right? This length will be the same as this length. And we're going up so that we know that this y-coordinate is also 1/2. This length is going to be the same as this length, except this time we're moving to the left. So this becomes negative radical 3 over 2. And we can continue around the unit circle and fill in the rest of these ordered pairs. So I would have this is moving left radical 3 over 2 and then down 1/2. So negative radical 3 over 2, negative 1/2. And then finally we go positive radical 3 over 2, down 1/2. So radical 3 over 2, negative 1/2. And what we've just done is we've filled in that first set of angles. Okay, so next up, let's do the one that's most closely related to that 30, 60, 90 triangle. Let's go ahead and talk about the 60-degree angles. All right, and so what we're talking about is this rotation here. Okay, so all of these represent a rotation of 60 degrees from the x-axis. So 60 degrees, once again, if you want to convert that to a radian measure, is just pi over 3. Now we can continue to move around the unit circle doing exactly what we did previously. To get to, let me put my points on here, each of these rotations, each of these points, I have to think about what my movement is around the unit circle. So I'm rotating from here all the way to here. But this angle represents a 60-degree difference from 180. So that's where the 120 is going to come from. The next angle we have to get all the way here, we're going to go all the way around. We get to 180, and then we keep going another 60 degrees. So 60 plus 180 is 240. And then to get to here, we rotate all the way around, and we stop 60 degrees short of 360. So that would be 300 degrees. Okay, and then we can think about our radians. So 60 times 2 gives me 120. So then we multiply pi over 3 times 2. 60 times 6 gives me 240. I'm sorry, 60 times 4 gives me 240. So then I would multiply pi over 3 times 4. And then finally, 60 times 300 would give me, 60 times 5 would give me 300. So I multiply pi over 3 times 5. And now I've got all of the angles. Okay, so now let's work on our ordered pairs. So what we have at this point is another 30, 60, 90 triangle, and I can use the same thinking that we just did a moment ago. Across from the 30-degree angle is going to be the shorter side, which will be half of the hypotenuse. And then across from the 60-degree angle is going to be radical 3 over 2, because it'll be the shorter leg times radical 3 over 2. And just like we did in the previous example, this represents the length, represents our x-coordinate, and the height is going to represent our y-coordinate. So I have this coordinate 1/2 comma radical 3 over 2. And then from that, I can build the rest of my ordered pairs. Go ahead and pause the video here and see if you can fill in the other 3 remaining ordered pairs. All right, so make sure you've got the 3 ordered pairs that I have written down here: -1/2 radical 3 over 2, -1/2 negative radical 3 over 2, and 1/2 negative radical 3 over 2. Okay, we've just got one more set of angles to find. So our last set of angles is going to be our 45-degree angles. All right, so let's work on building those. Okay, so our 45-degree angles are going to be right here. They're those middle angles in each quadrant. Okay, so each of these represents a 45-degree rotation. So if we want to think about how to write these in radians, again, just convert 45 degrees to radians based on what you did in a previous video. Now to write in the angle measures in degrees, we're going to do the same thing we did before. So take 180 and subtract 45. I guess I could put my points in here. Take 180, subtract 45, take 180 and add 45, and then take 360 and subtract 45. So go ahead and fill in those angles and come back. So we have 135, 225, and 315. Now the radian measures can be a little bit trickier because it's not always obvious what you're multiplying 45 by, but you can always do it backwards, right? 135 divided by 45 is going to be 3. So that means I have to multiply pi over 4 by 3. Okay, so I get 3 pi over 4. I can do 225 divided by 45, and you're going to get 5. So then this would be 5 pi over 4. And then finally, I can take 315 and divide it by 45, and you're going to get 7, which is then 7 pi over 4. All right, now let's figure out the coordinates. So a lot of people don't always intuitively know what this is going to end up being, but we have this 45, 45, 90 triangle. Again, the radius is 1. That's the same as all of our other triangles in this unit circle. What the relationship is that we can take the hypotenuse and divide it by radical 2 to get either of the legs. Now, when you do that and simplify it, you end up with radical 2 over 2. Okay, so I'm not going to go through that process again. If you need help with that, let me know. But the division of 1 divided by radical 2 gives me radical 2 over 2. So that tells me that the movement to the right is radical 2 over 2. That's going to be my x-coordinate. The movement up is radical 2 over 2. That's going to be my y-coordinate. And then I can repeat those movements for all of the other 45-degree angles, except I have to move left, right, or up and down, depending on where I am. So go ahead and pause the video and try that and come back. All right, so you should have negative radical 2 over 2, positive radical 2 over 2. They're both negative in the third quadrant, and then just y is negative in the fourth quadrant. So next up, we're going to actually practice with using the unit circle. So these are the 6 angles that you have on that previous example. So let's go ahead and work through these. The sine of 180 degrees, you find by looking at the 180-degree angle, and we've talked about how in the previous examples, how sine is directly related to your y-coordinate. So this is just going to end up being 0. Next up, we have cosine of 5 pi over 6. So we locate 5 pi over 6, and then we say that cosine is the x-coordinate of that ordered pair, so it's just negative radical 3 over 2. This is what using the unit circle will look like. Now, cotangent of 240, it's a little more interesting. So 240 is here. Cotangent is the reciprocal of tangent, or it's the cosine value over the sine value. So we're really saying it's the x-coordinate over the y-coordinate. So what that looks like is this. It's going to be negative 1/2 over negative radical 3 over 2. And then what we end up doing is negative 1/2 times the reciprocal of negative radical 3 over 2. And then we have our giant ones. So negative 2 and negative 2. That leaves us with 1 over radical 3. Now, that's not a bad answer, but one of the things that we want to make sure we do with the unit circle is rationalize the denominator. In other words, we're going to multiply the numerator and the denominator by radical 3 so that we can get it to where our fraction is just a fraction without any radicals in the denominator. Okay, next up, tangent of negative 60. So this one requires a little bit of thought. Normally when we rotate counterclockwise, we get our positive angles. But here I want a negative angle. So I want to rotate backwards 60 degrees. If I rotate backwards 60 degrees, that puts me right here at this ordered pair. So really, the tangent of 60 degrees is the same thing as saying the tangent of 300. Either one means the same thing. And guys, you can do that by finding coterminal angles, just like you saw in your previous lesson. So the tangent of 300 is going to be the sine over cosine, which is the same as saying your y-coordinate over your x-coordinate. So if I look at 300 degrees, y-coordinate over x-coordinate is going to be negative radical 3 over 2 over positive 1/2. Negative radical 3 over 2 times the reciprocal of 1/2. We cancel out our giant ones, and we get negative radical 3. Okay, secant of negative 7 pi over 4. Now, once again, you have to find a coterminal angle here by adding 2 pi or by just rotating backwards negative 7 pi over 4. So, think about it like this, okay? Negative 7 pi over 4 is really 315 degrees. So I'm going to rotate backwards 315 degrees, which is going to put me here. Now, you could also have found a coterminal angle for negative 7 pi over 4, but really what we're finding is the secant of pi over 4. Those two things are really the same thing, okay? So we can think of it in either term. So the secant of pi over 4, or the secant of negative 7 pi over 4, means do the reciprocal of cosine. Cosine is our x-coordinate. So I'm going to do the reciprocal of radical 2 over 2, which ends up being 2 over radical 2. Now, just like we saw in the previous example, I don't like having a radical in the denominator. So I'm going to go ahead and multiply top and bottom by radical 2 over 2. And what that gives me is 2 radical 2 over 2. And then once again, I have a giant 1 here that I can cancel out. So what I end up with is just radical 2. Okay, last but not least, cosecant of 19 pi over 4. So what we'd have to do here is find a coterminal angle by subtracting 2 pi. And what you're going to end up doing is cosecant of, so you can subtract 2 pi, and if you do that, you're going to get 11 pi over 4. I can subtract 2 pi again, and if I do that, I'm going to get 3 pi over 4. So really, cosecant of 19 pi over 4 and cosecant of 3 pi over 4 are the same thing. So I'm going to look at 3 pi over 4, and cosecant is the reciprocal of sine. So that's the reciprocal of my y-coordinate. Now, we just did that, right? We just did 2 over radical 2. So we know that that's just going to simplify to be radical 2. All right, nice work. Go ahead and check in with any questions you have, and I will see you soon.